Okay, so second to last section for this week is 7.3, and it's on solving trig equations, a little bit with inequalities, but we're going to do it graphically. So eventually, we'll start out with a review problem. That's from yesterday. But we're going to get into ones like this. We've never graphed anything like this before. Okay? First of all, it's got exponents on the trig function. We've never seen that. And it has two trig functions in the same problem. So there's some stuff I need to explain before we can get to this problem. But once I explain it, this problem will be very easy to do. So this part is kind of a review. It's just the basic idea again that if you've got to find solutions to a trig equation, find all the answers in one cycle. And then to represent the answers forever, you just have to take into account the period of the function. Okay? So the idea is usually we put a plus. You find one solution, and then you put plus the period times n. Now, most of the time, the period is either 2 pi or 1 pi. Okay. I'm going to give you guys a chart in a little bit that summarizes all the periods of different trig functions, whether you use 2 pi n, 2 pi over n, or pi over n. I'm going to show you when to use which one. Most of the time, the period is either 2 pi or 1 pi. Okay, so you guys did all this yesterday. In fact, that's the last question that Brianna just asked me about in the homework. Okay. Find all the solutions using second calc intersect, and then put plus period times n. You just got to make sure you get this right. That's what I'm going to show you how to do on the next couple of slides. Now, even though we're solving equations graphically today, some of the problems we're doing you could do non-graphically, meaning you could do algebra. I think it's later in chapter 6. No, later in chapter 7. We're going to come back to some of the problems we're doing today, and we're going to do them again, but we're going to do them with algebra. Okay. Not every problem can be done easily with algebra. Every problem can be done graphically. Just type it in and see what it looks like. Using algebra, that can be a little bit harder. But the advantage of algebra is you can get the exact answer. The calculator will always give you a decimal. It'll never give you an exact answer. But for today, I'm okay with decimals. Okay, so let's try this one. Just a review problem from yesterday. Can someone remind me how we would solve something like that on the calculator? Chris?
I have y1 be sine x.
Yep, which actually I already have from a homework problem.
I have y2 be 0.8.
Y2 is 0.8. And when I graph that, how many cycles do I want to look at? Just one. And what's the width of a cycle of the sine function? Yep, Caleb. 2 pi, I think I already got it in there from before. So 0 to 2 pi works. Don't have to worry too much about the y min and max because I already know it only goes 1, negative 1. Jacob, how many answers am I going to get per cycle?
2.
We're going to get 2. So we're going to start out by finding each one of them. Second calc intersect. Okay, there's one of them, 2.21. And the other one, just move your cursor closer to it and you should be fine. 0.93. Now, if you just do that, you haven't done that. You found 2 solutions to that problem. I want all of them. So what do I have to put to represent all solutions? Yeah?
Plus 2 pi n.
Right. that answer will repeat every single cycle. So that's why you put plus 2 pi n, plus 2 pi n. Okay, so if you want the next answer after 2.21, add 2 pi. If you want the answer after that, add another 2 pi. If you want the one after that, another 2 pi. You can just keep adding 2 pi. And remember, n is an integer that represents how many times you've added 2 pi. Or if n is negative, it would be subtracting 2 pi. So you'd be getting the answers in the cycles before instead of the cycles after. Okay, questions on that? So for the rest of the problems, the idea is the same. You have to put plus period times n, but it's going to be a little bit more complicated to find the period because it's not just going to be a single trig function. You can have multiple ones, or you might have one raised to a power. So what we're basically doing here is we are solving for the, if you get the equation equal to 0, right? It's like, let's take this last problem. Sine of x equals 0.8. And let's say that instead of giving it to you that way, I gave it to you like this. Is that the same thing? What do you think? Eric? Yeah, I just moved the 0.8 to the other side. Well, if you want to solve it that way, you can, but what you'd have to use is the 0 feature of the calculator. Okay? Solving it this way basically allows you to put everything into the same function. Sine of x minus 0.8. But since you only typed in one thing, you're not looking for an intersect. There's only one thing. You're looking for where it crosses the axis now because you set it equal to 0, and that's called finding the roots. It's exactly what we just did in the last problem. Except now you press second calc and press 0. Okay. I'm just going to do one of them. Okay. You pick a point to the left, pick a point to the right, do your guess, and there's your 0, 2.21. It's exactly the same answer that we just got. So when it's equal to 0, they just call it something different. You're finding the roots. When it's not equal to 0, you're finding the intersections. But the answers are the same, because it's the same equation. Questions on that idea? Okay. So, how do you find the period of a complicated problem like this? You've got two different trig functions, and you've got one of them to a power. Well, we'll talk about the power after. But in general, what you have to do is look at each periodic term in your equation. That's a periodic term. That's a periodic term. The one that I just drew an arrow to? No. That's a term, but it's not periodic. A periodic term has to be a trig function. Okay? If you graph cosine squared, it's going to repeat itself. If you graph sine, it's going to repeat its pattern. If you graph the number 1, no. It's just a horizontal line. We don't call that periodic. Okay. So you got to identify the periodic terms and find the period of each one of them. Now, once you have those individual periods, if you take the least common multiple of all of them, that's the period you're looking for the whole problem. Okay. So just to kind of show you, like, if you had the number, let's say, 3 and 7, and you wanted to figure out the least common multiple, I could make a list of multiples of 3. 3, 6, 9, 12. Okay. So there's multiples of 3. Now I could make a list of multiples of 7. And I could keep going. The least common multiple is the smallest number both lists have in common, which in this case is what? 21. That's the least common multiple. Now, if I now said to find the least common multiple of 3 pi and 7 pi, it's the same thing. The only difference is instead of the least common multiple being 21, it's going to be 21 pi. So 3 pi, 6 pi, 9 pi, 12 pi. All you have to do is list out the multiples. 7 pi, 14 pi, 21 pi. It's the same idea. And find the smallest one in each list. This is how your problems are going to look today. You'll have two numbers with pi, and you're going to have to find the LCM. Okay. So, right now, if we go back to that problem for a second, we should be able to find the period of one of those boxes. Which box do we know how to find the period for already? We've done it before. Yeah? We do. We know how to find the period of sine. What is the period of regular old sine? Yeah. 2 pi. So when we get to this problem, we know that part. The problem is we don't know how to find the period of a trig function raised to a power. So I'm going to give you a table that shows you how to do that. Now, what it really boils down to is whether it's raised to an even or an odd power. Okay? That's what we're going to kind of look at. So, for any problems that fall into this pattern, sine to an even power, cosine to an even power, secant to an even power, cosecant to an even power, or any tangent or cotangent, even or odd, doesn't matter. The formula that you use to find the period is 2 pi over b. Remember, b, I'm just going to put this here, is the coefficient of x. The reason I put absolute values around it is because if b was ever negative, you don't want to use the negative because t has to be a positive number. Because t measures the length. Length can't be negative. So the other cases we have that aren't up here are sine to an odd power, cosine to an odd, secant and cosecant to an odd. If you have one of those cases, I have to wait because I can't really scroll down without making it really small. Does everyone have the top 6 ones? So those are the last 4. Sine, cosine, secant, and cosecant to an odd. Does anyone remember the other formula we used? We used pi over b. And the other one we used was 2 pi over b. Yep. So the formula here is 2 pi over b. Again, b is the coefficient of x, whatever number is in front. So you might be able to come up with a better way to organize that in your notes so it makes sense to you, but that's what you need to know. Okay, so look at your trig function, look at the power, figure out if it's even or odd, and then use the appropriate formula from there. Okay, so let's take a look at what we've got. Cosine. In this case, is that cosine to an even or an odd? It's an even. Cosine to an even power, it says to find the period, use the formula pi over b. Remember, b is the number that's in front of your argument. What number is in front of the t in this case? What is it? It's just 1. So the period of cosine squared We don't even have to graph it to figure it out, is just 1. So now, you have to find the least common multiple between pi and 2 pi. And that's going to be the period of this whole problem. So, what's the least common multiple of 1 pi and 2 pi? 2 pi. It's like asking you what's the least common multiple of 1 and 2. Okay? It would be 2. So now, when you get your answers to this problem and you put plus the period times n, that's the period in this problem you want to use, 2 pi. Okay. Now from here, we just need to graph that equation. Am I going to be using y1 and y2, or is everything going in y1 in this case? Yeah. Everything's going into y1 because it's equal to 0. They've set it up so that I'm going to be finding the roots. Okay? I'm not doing an intersect. If there was something on the other side, I could do it that way. But this time there isn't. Now, in order to type in a power, how you write powers on paper and how they look on the calculator are different. You can't type something like this in on the calculator. So the way it's going to look on the calculator, that's what it looks like on paper. This is what it's going to look like on the calculator. Those mean the same thing. Okay? So let's type that in. So 2 cosine x squared. Okay? Or this is also the same thing. Depending on your calculator, it might look either way. The problem, what you don't want to do is this. That is not the same thing. That means take t, square it, and then take the cosine of that number. No. You want to take the cosine of the number first, and then square it at the end. That's the order of operations that's happening. Okay, so 2 cosine x squared plus sine x plus 1. Okay. Now, make sure you set your window to be 1 cycle. We know that this graph has a cycle of 2 pi. That was the LCM. Let's leave it at -5 to 5. If that's not good enough, we'll fix it. And there's your graph. That's 1 cycle. So if I just put that here, make it a little smaller, I can trace it. Looks like that. Now if I copy and paste that multiple times, that's what this graph would look like if you zoomed out. That's the graph you're looking at. You're looking at 3 cycles right there. Okay. So let's go back to this. How many times does it look like that graph crosses the x-axis? I mean, what could it be? Yeah? Could be 2. What else could it be? Could be 1. I think what we want to do is probably just zoom in a little bit. There's no question that it doesn't cross anywhere else. Does everyone agree that it only crosses where my cursor is? There's nowhere else that's even close. So it's okay to now zoom in. It's a complicated trig function, so it does take a little bit longer to draw it. It's still kind of hard to see. I'm leaning towards it. It's just coming down and touching it one time. We can zoom in if we want one more time. And if it still looks pretty close, then it's probably just once. It almost looks like it could be twice, but the way we can figure it out is we can go second calc 0. Pick a point to the left that you know. Pick a point to the right. Now, if it gives me an answer exactly in the middle, then I know it only crosses once. If it gives me an answer kind of off to the side a little bit, then there's probably another answer off to the other side. Right? So we'll see where it gives me the answer. It's exactly in the middle. So that means that's the only route. Okay, if it was off to the side a little bit, then I'd say, okay, there's another one off to the other side because it would have dipped down and crossed in 2 spots. But since it gave me it right in the middle, it's only going to be 1. Okay, so the answer we want is 4.71. And since they want all answers, what do I want to put on the end of that? Yep. Plus your least common multiple, because that's your period, times n. Yes?
Mine just graphed straight.
Yours graphed, are you in radians?
No.
Yep, so that's the problem. You can do this problem in radians, but instead of 0 to 2 pi, you're going to go 0 to 360,
Got it.
which is a lot bigger. Yeah. Okay. All right. Let's take a look at this one. Now, this one is set up so you could do a y1 and y2, or we could move everything to one side. Since that's what we've done for the past problem, let's do that again here. How could I get this equation equal to 0?
Just subtract tangent from both sides.
Sure, I could subtract tangent of x from both sides. Doesn't really matter how you do it. Just subtract tangent x from both sides. And now let's put that all in y1. Now, before I type it all in, what does the graph of tangent have? Or what makes that different than sine and cosine? Yep. Yeah, it goes up and down forever, which means that it has what? Yeah.
Vertical asymptotes.
It has vertical asymptotes. So this graph is also going to have vertical asymptotes. It's not going to look exactly like tangent because it has that 3 cosine part in the front. Now, I can type it in to graph it, but I won't be able to set my window because we haven't found the period yet. So let's start with cosine. When there's no power on something, what power do you always assume? Sam?
1.
1. So that's cosine to an odd power, basically. Okay, look back in your notes. What's the formula that I use when it's cosine to an odd power? Yep.
Pi over b.
And what's b in this case?
1.
Yep, so it's just 2 pi over 1. That's why the period of cosine is 2 pi. We probably already knew that. What about tangent? Is that an even or an odd power? That's odd. What's your formula for tangent to an odd power? Yep. Pi over b. And what's b in this case? Let's just divide by 1, so we don't even need it. We just did that in the last problem. What's the LCM of 1 pi and 2 pi? 2 pi. I'm not going to say it's going to be 2 pi every time, but it does come up a lot. Right. So when you write your answers, that's what you're going to use plus 2 pi n, and that's what you're going to set your window to in order to see one cycle. Since I zoomed in, I need to fix it. Let's go 0 to 2 pi. Now, as Brianna said, tangent's going to go up and down forever, so we can try, like, I don't know, maybe -8 to 8, just to get an idea of what it looks like. But you're never going to see the top or the bottom. And then minus tangent x. Okay. So there it is dropping off and going down forever. There it is going up forever. Now it looks like this graph is in 3 pieces, but if you drew it correct, if you actually drew it a little differently, this piece and this piece would connect to each other. Okay? Because this piece would start right here in the next cycle. So it really could be sketched as 2 pieces rather than 3. But the cycle, the way we broke it up, it is 2. It is 3. And how many times does it look like it crosses the x-axis? Twice. There's really no question here at all. So second calc, 0. I'm going to do the one in the middle. If somebody else that has it graphed can do the first one right here, that would be helpful. So the second answer is 2.13. And does anyone have what the first answer is? Yeah.
0.01.
1.01? Now, we haven't quite done what they wanted. They said all. You found 2. So what do we have to put on those to represent all? Emily? Yeah. Plus your LCM, which is your period, times n. Okay. And that's it. Questions on it? Okay, so one of them we did had 1 solution per cycle. This one had 2 solutions per cycle. I mean, you can have all kinds of things happen. Let's look at this one. So 3 sine cubed 2x minus 2 cosine x. Okay. There are 2 periodic terms. That's a term. That's a term. Remember, terms are separated by addition and subtraction signs. So there are 2 terms on the left. Okay. Sine to an odd power. Kara, what's my formula for sine to an odd power? Yep. 2 pi over not sure. Chris, you know, bro, what is it?
2x.
No. Shouldn't be any letters in this formula. I mean, except the Greek letter pi, but that's actually a number. 2 pi over. Well, so where are we? Well, what letter are we looking for in the bottom before we plug the number in? It's 2 pi over
B.
B. Now, where's B? Yeah.
In front of the x.
It's the number in front of the x. So what are we plugging in for B? 2. So the period of sine cubed 2x, the fact that it's to an odd power has an effect on the period. The fact that there's a 2 in front of it, in front of the x, also changes the period. So what's 2 pi over 2? Pi. So that's the period of the first term. What's the period of cosine x? Just basic cosine. Okay. Do you have your formulas? Did you write them down?
Yeah.
So that's cosine to what power?
This one.
1, which is what kind of number? Yep.
I didn't get the formula.
So what's the formula for cosine to an odd? Chris?
2 pi over
Yep. And what's b in this case?
b.
1? So it's just 2 pi over 1, which is just 2 pi. This has happened on every problem we've done so far. What's the LCM of pi and 2 pi? 2 pi. Again, it may not be 2 pi every single time, but a lot of them today are. Okay. So this tells us we have to put a plus 2 pi in on each answer. Also tells me how to set my window on the calculator. I've been using 2 pi right along, so that should be fine. 3 sine cubed 2x. So this is how you type it in. You're not cubing the 3. You're only cubing the sine, so be careful, because if you cube the 3, you're going to turn it into 27. You don't want that. So put the 3 there, then parenthesis, sine x, close the parenthesis, and then cubed. That's how you can type it in. So 3 sine cubed, except I should have put a 2 in front of the x. Forgot about that. Okay, so 3 sine 2x, and we're going to cube it. Minus 2 cosine x. And we're looking for how many times it crosses the x-axis. Yeah, it's going to take a little while to draw it because it is kind of complex. So, how many times does it look like that crosses? Yeah, I think 6. So you get 1, 2, 3, 4, 5, 6. So you would have to do second calculated zeros 6 times. It's just kind of tedious, but it's not really any harder. It is longer. I already have the answers, so I can just tell you what it comes out to. So you're going to get an answer at 0.5. You're going to get one at 1.25. You'll get one at 1.57, 1.89, 2.65, and the last one kind of goes over a little bit, 4.71. And every one of these should have what added on to the end of it? Okay. Plus, I'm just going to write it like this. I mean, technically, that's not really how the book would do it. They would put plus 2 pi n on each one of them separate, but you know it. You probably wouldn't have one on a test with that many answers, but I'm just showing you that you can have, I mean, that is one with 6 answers per cycle. But more typical ones that we're going to do probably have, I'd say, anywhere from 1 to 3 answers per cycle. Okay. Questions on that one? So, let's finish up by looking at a few inequalities. So, inequality is pretty much the same thing. You still have to find all the roots, or intersects if you do it that way. But you still have to find all those numbers. But remember that the answers now are intervals. So the answer is usually going to be like, let's say you had a graph like this. And you wanted to know where that graph was below 0. What would be between here and here? So we're going to use intervals, brackets and parentheses. Whether you use a bracket or parenthesis would depend on if it said less than 0 or less than or equal to 0. If you have a problem with vertical asymptotes in it, the vertical asymptote is going to be very easy to find. Okay? It's not going to be a complicated one. So when we do one like that, you'll see what I mean. But in general, I mean, you could make the vertical asymptotes very, very difficult to find. So, but these problems, it will not be hard to figure out what it is. So first we're going to look at a couple just basic single inequalities, and then we're going to finish up with what's called a double inequality. Double inequality is when you have something like this. Yours is going to have trig in it, but that's an example of a double inequality. Saying x is between 3 and 5. That's an example of a single inequality. X is greater than or equal to 3. Okay, so let's try this one. Now, we can do it like that, or we can get it with 0 on one side. We've been doing 0 all class, so I'm going to keep doing it that way. If I want to do it that way, how would you put cotangent on the left? Jake, how would you put the cotangent on the left? And leave 0 on the right.
Swap it for negative cosine? Or
So the only way we can move it is we can either add, subtract, multiply, or divide. You have to pick one of those. Sure. Yeah, that one. That wouldn't leave you with a 0 on the right. You could move it that way, it just won't leave you with a 0. But that is something we may do at some point for something else, but just not today. Yep.
Check cotangent for both sides.
Right. You subtract cotangent from both sides, now you have something on the left less than 0. Okay. Now, first let's find the period. Period of sine is 2 pi. Period of cotangent is pi. You can look up on your chart how I did that if you're not sure. Least common multiple, this one's come up a bunch of times. It's 2 pi. Okay, so that 2 pi, we're going to keep that in the back of our mind when we set our window. We're also going to use that when we write our answer. Okay, now we have to type in sine minus cotangent. Well, sine is easy. How do I type in cotangent? Yeah. Yep, we're going to type it in as 1 divided by tangent. So that's sine minus cotangent. I'm already set up for one cycle. Perfect. So we're looking for where that graph is less than 0. Once it finishes, I'll drag it over to the screen so we can look at it. And you might think, well, geez, now you're looking at 2 cycles because it's the same thing repeated. No, those curves aren't the same. If you look closely there, they wouldn't match up. They are different. Okay. How many sections in that graph are below 0? Yeah. 2. This section right here, which is bounded by a vertical asymptote, and this section right here, which is also bounded by a vertical asymptote. But what we have to find is this and that. So we have to find those 2 points just like we had to do before. All right, let's start by doing, I'll call this interval 1, I'll call that interval 2. Interval 1. What's the left edge of interval 1? What number is it at?
0.
0, including or not including? Not including. Not because it's a less than, it's because it's an asymptote. You can never include an asymptote. So we're going to go from 0 up to, now we need to find that point that I just clicked on. Second calc 0. Pick a point that you know is to the left. Right? Pick a point you know is to the right. Do your guess, and it's let's see, about 0.90. Is that about 0.90? Now, should I include 0.90 or don't include it? Why not? Right, it's less than 0. It can't equal 0. So that's interval number 1. Or, put that in symbol. Now we describe interval number 2. Is the left, even if you don't know the number yet, is the left edge of interval number 2 going to be including or not including? Why? It's another asymptote. Now I told you the asymptote would be easy to find. What's the width of that screen you're looking at? It's from 0 to what? 2 pi. Where does it look like the asymptote is? It's right in the middle. And you can check that by going to your table, trying the value right in the middle of 0 and 2 pi and see if it's the asymptote. What's the value that's in the middle of 0 and 2 pi? Pi. So type in pi. Oops. Second, pi. Sure enough, it says error, which means pi is an asymptote. Okay. So, pi up to the second dot in interval 2. Now, I don't even know it yet, but is it going to be bracket or parenthesis? Right. It's parenthesis for the same reason the 0.9 was parenthesis. So second calc 0. Take a little while to get over to that other point. Just get over to it. There. And as long as that y value goes positive, you know you're good. So the other answer is 5.38. Now, you haven't done that. That's the easy part. All you've told me is 2 specific areas where it's less than 0. How often does region 1 and region 2 repeat? Every what? Every cycle, which in this case is every 2 pi. So what you might see in the book is plus 2 pi n on every one of those numbers. Okay? What I'm going to do is I'm just going to put it on the whole interval. Plus 2 pi n to interval 1, plus 2 pi n to interval 2. As long as you understand that that means you can add 2 pi n, but you have to do it to each number. Okay? And that would shift you over to the next cycle. All right. Any questions on it? Yep.
Can you just go back to the screen where you put data? I was just curious that you put it over.
Yep. So we did it as 1 over tangent. Not the only way to do it. You could do it another way too, but.
Just press alpha F1 and then you put in a fraction.
Alpha F1.
Or alpha, then the y equals, and then 1 should allow you to put in a fraction.
Oh, maybe, yeah, maybe I've never used that before, but yeah, maybe you could use that too.
And I think 2 is a mixed number.
A mixed number. You wanted to put that in? Yeah, maybe that would work. I'll have to try it. All right, let's try this one. Now it just says graph it as it is. Don't move anything around from side to side. Okay, so let's put in sine 2x and x squared minus 1. So remember, x squared, that's a parabola. So I'm going to have a sine wave, and I'm going to have a parabola. And I want to know where the sine wave is above or equal to my parabola. Okay, let's do zoom. I'm just going to do zoom 7 to start me off. So you can clearly see the sine 2x is periodic. It's repeating itself over and over. Okay, look at the parabola. Is the parabola periodic? No, the parabola doesn't repeat over and over and over. So when you find all solutions to this problem, you can see it right on the screen. There are no answers that go off the screen because the parabolas don't keep repeating off the screen. The only answer to this problem is from here up to there. That's the only section in this whole problem that the answer is. Okay? So you do not put plus 2 pi in because the parabola doesn't keep repeating. If it did, then you'd get another answer like over here and over here. But the parabola, it doesn't keep repeating. Okay. So to find the solution, we just have to find two intersects. The lower green dot and then the higher one. Okay, so the first one is negative 0.46. Include that or do not include it. Include it. It doesn't just say greater than, it says greater than or where the two graphs are equal. So negative 0.46 up to, let's go over here. 1.26. Do not put plus 2 pi in. Okay, we already said. Any questions before we look at the last problem? Okay. So, last problem is a double inequality. So, with a double inequality, you're going to have something like this. I'm just making one up with numbers. You're going to put what's on the left in y1. You're going to put what's in the middle in y2. You're going to put what's on the right in y3. And you're going to be looking for where the y2 graph is sandwiched between y1 and y3. Okay, so we've got negative x, x sine x, and x. So let's graph it. So we've got negative x, x sine x, which it's probably better to just clear it first if you got something else in there, and x. So what I'm going to be looking for is where the graph in red is sandwiched between the blue and the black. So if you want me to underline them so you can remember what they are. I think that one was, is that one blue? Yeah. So if you're thinking in terms of colors, you're looking for where the red is between the blue and the black. Okay, let's see where that happens. I'm going to do zoom 7 just to get an idea. So there's the left. There's the sine wave in the middle. Now, I can't really tell that good what's going on here, so I'm gonna zoom out so I can see it a little bit better. So I'm going to do zoom 3. Hit enter. It's just going to zoom out. So there's the left. Now we can see it a lot better. There's x sine x. And here's the right, y equals x. Okay. So the question is, where is the graph in red above the graph in blue, but under the graph in black? Right. So from which x value? Chris?
0?
Including or not including? Including. And up how high? Yeah, like from, so we're going to write this as an interval. So you said from 0 up to infinity. Just keeps going. Every value from 0 on, the graph in red will always be above the blue and under the black. Or equal. So that's why we can use the bracket, but you can never equal infinity, so we don't use the bracket. Okay, question on that? Alright, so now we'll try one more. Almost the same thing, except the middle is the same, but I'm going to put negative, and then I'm going to put absolute value x, and then positive absolute value x. So we're going to go negative, math, number, absolute value x. And we're going to go math, number, absolute value x. Now, if you don't have color on your graph, this is where this one might look a little confusing because of the one we just did. I'm going to graph it, and I want you to compare the one that I'm graphing now to the one that I did before. And what I really want you to kind of think about is, what if these graphs were black and white? So how would these two graphs compare to each other if they were black and white? They'd look exactly the same. But by doing them in color, what's the difference? Yeah?
The blue line is only below x. Black line is above the x-axis.
Right, so you're getting an X shape, but you're getting an X shape on the left because you drew two lines that crossed. You're getting an X shape on the right because you drew two V shapes. It's not the same. They look the same kind of, but they're not the same. So now the question, let's bring this down. This one. Let's get rid of that. Where is the graph in red above, this one was the blue. This one was the black. Where is the graph in red above the blue, but below the black? Yeah, everywhere. So how would you write that as an interval?
Not including negative infinity to infinity.
Right. That's always true, no matter where you look. Okay. So that's why, and you can still do this on a calculator that doesn't have color. You just have to look very carefully and look closely, but the color does kind of help in this case. Any questions on that? Okay. So homework tonight, kind of, it skips around a lot, so it's 401, 5, 7, 12 to 15, and then after that it's odds. 19 to 23 odd, 29 and 31, and 33 to 37 just odds. So we'll go over that tomorrow, and then tomorrow will be our last day of new material for the week, and Thursday we'll do a reviewing class for the tests on Friday.